Consider two pairs of random variables xy and wz with the following joint PDFs. So the joint PDF of xy is 4xy, x from 0 to 1, y 0 to 1. And then we have this joint PDF of w and z, which of the following are correct. So we are to decide about the covariances. Now, we know that if a joint PDF can be written as a product of the entirely the functions of the individual variables, and the region of integration is a rectangle, then the two variables are independent, and that means covariance is 0. So in this case, we see that this can be separated out. So this can be written as 4x times y, and 4x is entirely a function of x, and y is entirely a function of y. And the region of integration is a rectangle because x goes from 0 to 1, so that's and y goes from 0 to 1, so that's a square or a rectangle where length and width are 1. So both the conditions that we just mentioned are met, and therefore x and y are independent, and that means the covariance is 0 because covariance of independent variable is 0. And now for the w and the z, we notice that, so look at the first two parts. So in the first part, w is from 0 to 0.5, and in the second part, it's from 0.5 to 1. So in the second part, the w has increased, the w range has increased. Initially, it was 0 to 0.5, and then in the second part, it's 0.5 to 1. However, the z range decreases as w increases. So when w was smaller, the 0 to 0.5, z was 0.5 to 1. But when w became larger, 0.5 to 1, then z shrinked from 0.5 to 1 to 0 to 0.5. So we see that as w increases, z decreases. So which means that w and z are negatively correlated. So the correlation coefficient is negative, and the correlation coefficient between two variables is negative, and that means their covariance is also negative. And so the conclusion is that covariance of x and y is 0, and the covariance of w and z is negative, and that was choice B.